Hi, and welcome. I'm Duke McDowell with Sterling Custom Homes. I want to personally thank you for taking the time to watch this video. Today we're going to look at some of the estimating that we do and how we actually go through our plans behind the scenes to potentially find problems that exist in the way the architect or somebody may design the actual house. We do it through a 3D rendering program. So let's get started and let's look. Okay, so we're here at this 3D modeling program, and as you can see, we've kind of gone from all of the 2x4s, 2x6s, 2x8s, 2x10s, and the frame look down into the actual cover look by putting a roof on it, stucco and stone. So you'll notice in the area as we go through, there's a wall that's sticking through the roof. That's a problem. So we want to address it now and not address it when we're actually out there framing the house. So you'll see from the 3D modeling, it shows some of the points where there are potential problems that people haven't thought of as they designed the home. So we go over to another area and you see a little brown area up there at the top that you see is circling. That is actually a beam, that's a structural beam that's sticking through the roof and coming down through that valley as it passes through for bracing purposes. So that's a problem as well. So how do we address these? So we begin to go and we look at the frame section of it, which the frame section is going to show you the roof rafters, the wall. You see the wall there that as he begins to circle it, you see the wall extending into the other exterior wall, and that's what's creating some of the problem. And you see ceiling joists there actually needing to be braced up on something on top of that wall. Well, how are we going to fix that? We'll attend to that here in just a second. Let's roll over here and let's look at the beam that's sticking through into the valley. That's the brown piece. That beam is there designed for purposes, again, of structural integrity of the house, and so we can't eliminate that beam. What we're going to have to do is figure another way to use that beam, because we can't have it sticking through the valley. That would be a little bit problematic. So let's kind of go back over to the first one where the wall was going through through the rafters, and then you'll see some brown studs, and then you'll also kind of see as we take and turn it and rotate it a little bit for you how we actually fix that and keep that wall from going through our rafters that would then create a whole problem in itself. You'll see too where we're kind of showing you with the marker what we call a dead valley, and that dead valley down in there is a little bit dangerous in the industry. We prefer not to have dead valleys if we can avoid it. They can be flashed, but they're somewhat a little bit problematic, and we'll get back to that here in just a few minutes about how we actually address that. So let's rotate over and we're going to look at the beam. This is kind of the fix on how we actually looked at the beam. Remember, the beam was turned 90 degrees, and now what we've done is rotated the beam, pushed it back some, and then still used it on the rafters to allow us to brace to, and found a wall to it. However, that beam ended up being 2 feet longer. So how does this help us going through this process? Well, we had ordered the original beam. We would have figured out that it's sticking through the rafters, and then we'd have come back at that point in time and had to order another beam. That would have been 2 foot longer to actually go to the fix that we're looking at. So what does this do long term? This allows us to frame your house faster. It also saves the builder money, especially if you're doing into a cost plus deal with the builder. This comes in and saves the money of that original beam, and it stops the problem before it actually occurs. So as we go back and we rotate back over to that valley area that we looked at where that wall was cutting through, we're now going to kind of put the roof on top of it for you. And so now you kind of see that house as a whole with the roof instead of just the framing members. And now you're seeing that flashing that I kind of pointed out earlier as where that possible dead valley is. You also can see the other valley coming down into that wall. And with it coming into that wall, that's all of that water is going to be running down and hitting that wall and then working its way down to the outside. So that's part of that dead valley that we were talking about that's a little bit dangerous. Now kind of flipping back over the area where your beam and stuff was sticking through that valley, if you'll recall. Now with the turning of it 90 degrees, it's no longer the case. So kind of looking back at the outside of the house, you see some issues there. Now we've kind of moved over to the right hand side of some windows, and as you'll notice from those windows, there's some flashing. That's that darker gray color that's up there. There's some flashing that actually goes into those windows. So again, that's a problem, because when we go in, we're going to have to flash that area underneath the bottom of the windows, keep water intrusion from happening. We don't want the flashing to cut through the window. So what is our solution? Are we going to have to order a different type of window? Are we going to be able to slide the window up? You know, you can see some bands and stuff that are created at the bottom of the windows and the top of the windows. You have a soffit directly above it, but we obviously can't leave the flashing going through those windows. So we're going to have to address that. And where, you know, it's pointing now, you see the 1x material and stuff up there for the projection of those windows. So that's a problem that that we have figured out and seen now with using this 3D modeling program based on the header heights and everything else. Now, what does this do to us as we're out in the field? Well, we don't set the headers at the wrong height, and we also have the opportunity to change soffits, raise windows, do things like that ahead of time, so that the framer's not charging us money to come back and reframe windows that don't work, or whatever the case might be. As you continue through this, you now see our fix. Our fix now became, we took the 1x4 projection at the top off of there, we slid the window up, and by sliding that window up, we raised the header up behind it, and so therefore now we have a new header height that we have on our plans and on this program, so that we know what height to set that header at, and then now the flashing and stuff underneath the windows makes it all the way through. So now we have more of a seamless, set the window at the right place, and now we have the flashing in place for our roofer as well to make sure that he's flashing this area properly. So that kind of gives you an overview of how and why it's important for a builder to come in here with this 3D modeling program as they go through and figure out all of their takeoffs. Now, this also gives us quantitative analysis of all of the 2x in a house, along with walls and bracing and everything else, and gives us exact figures so that we know exactly what to order. So there's not a lot of credits. The lumber company likes it, because the lumber company goes out, drops all the lumber off. They don't have to come and pick up a bunch of lumber at the end of the day, nor do they have to continue to do what they call hot shots or small orders. That costs people money and time. So the framers love it. They're cheaper for us in the long run because of that. So now, the other part that, if you'll remember and recall, as you look at this, we had a dead valley kind of coming through there in that corner that I talked about, that's problematic for the water coming on and shedding off of there. So what we've created here is a solution to fix that. We've come in with the roof, and we've allowed the roof to slope down and take away that valley, that second valley in there. And by taking that second valley away, we've been able to slope the ceiling or the roof all the way down. That keeps it seamless, which will keep from the water dying into the side, as you can kind of see here as we circle around there with the dead valley versus what we're showing you, that we fixed the roof and changed the roof up, so it makes a better long-term effect for the customer on the roof design, along with the fact that it really doesn't change at all. This fix doesn't change what it's going to look like from the street appeal. And even though it's on the front elevation, you can see that it all kind of goes away, and our fix is a much better solution long-term for the house, you know, and the roof, because water will get up underneath that ridge, and water will continue to hit the side of that stucco, and it will begin to penetrate the stucco over time. So we really want to make sure that as we go through the process, your builder actually looks at all of these possible solutions as well as possible problems with a design that comes from an architect through a set of plans. This 3D modeling is important, I think, for us as well as for you, the client. Okay, thank you very much for taking the time to go through this with us. If you have any questions, be sure to give us a call or also visit us on our website so that you can get some more information there or the YouTube channel. Thank you very much for all your attention and your time. Have a great day. Thanks.